Hello everybody, and welcome to our discussion of the day, which is about construction digital twins. And the question is, just how far does scanning technology get you? We have some great guests with us today. Welcome to the webinar. Just some logistics before we start. There is a Q&A tab in your panel. Please use it if you want to ask any questions. We'd love some questions from you. It does spice up the conversation a bit to get some real-time input, so please do that. We are going to record this webinar, so apologies if that's not to your liking, but it's useful to have other people to obviously listen to this afterwards. I'm going to be moderating the session. My name is Alan Behrens. I'll introduce myself in a minute, but this is being organized very kindly by AMC Bridge, so thank you to them for coordination. So let's take you to our attendees. We have 5 erstwhile panelists joining us: Corey Johnson, Steve Coombs, Matthew Bester, Hamzah Shanbari, and Andy Parnell-Hopkinson. I'll just ask them after I introduce myself to just give a bit of background on who they are, where they come from, and why this is a topic of interest to them. My name's Alan Behrens. I'm the moderator. My interest is in, I'm a subject matter expert on the intersect between technology and industry. And you know, it's of great interest to me to understand the views of the panelists and you, the audience, on this particular topic. So without further ado, let me just pass you on to each of the panelists and just give a couple of minutes on who they are and why this is a topic of interest to them. Corey, why don't you start us off?
My name is Corey Johnson. I'm the Senior Director for the construction portfolio here at Bentley Systems. My background was initially design, went into construction, and this topic is very prevalent. We keep talking about construction digital twins. With construction, it's nice to have a new 3D model, but the scanning technology to tie in, because every new project ties into existing or is improving existing. So very important topic and a very important thing for the industry to gain more experience on as we move forward.
Great, thanks. Steve.
Hi everybody, I'm Steve Coombs. I've worked for Ericsson for 25 years in various roles. Currently I'm responsible for getting digital twins and drone technology and scanning technology out into the hands of the field so they can better optimize the use of the technology that's available to make rollout of networks faster.
Great, thanks. Matthew.
Thanks, Alan. Hi, everyone. My name is Matthew Bester. I work for a company called Leica Geosystems, part of Hexagon. I'm looking after a product suite, which is called the Autonomy Suite. That falls within the reality capture division, and basically all to do with laser scanning. So everything from mobile mapping, aerial mapping, handheld, and so forth, terrestrial. The subject is quite interesting for me because we're the first step to get an existing building into the digital space. So we transmutate the reality into a digital format.
Great, thank you. Hamzah.
Yes, thank you, Alan. My name is Hamzah Shanbari. I'm the Director of Innovation here at Haskell. And Haskell is a design build company based out of here in Jacksonville, Florida. That's where I'm at today. And it's super interesting, of course, because, I mean, we are your end users. Everybody here is mostly kind of like the technology provider. We're the end users. We're the ones that actually going out to the job site and trying to capture that construction digital twin in order to keep track of, are we on progress? Are we installing things in the right place or not? So it's always an exciting topic, and that's kind of my role also in the innovation. Always constantly looking at what's coming, you know, down the pipeline, what's the next big thing, and testing it and making sure that it works well.
Great, thank you. Andy.
Yeah, thanks, Alan. Hi, everyone. My name's Andy Parnell-Hopkinson, and I represent AMC Bridge in Europe. I look after our business here. I'm based in the UK. But in my career, excuse me, I've spent more than 30 years selling digital solutions of one form or another into manufacturing, engineering, and construction in most parts of the world. So I've seen how people use technology for improving their processes, their route to market, their time to market, in many different contexts and many different countries. I've been with AMC Bridge only 3 years, but I discovered after I joined that I'd sold code written by AMC Bridge for 3 different companies I've worked for. So so yeah, we're always interested to see where the market's going and how we can help.
Excellent, thanks very much. And thank you at the start of the session for your time, gentlemen, and to you, the audience. I hope this is going to go really well. And to start us off, we're going to have a couple of polls. I think first we'd just like to understand, if we can get the poll on the screen, what's the current status of using scanning technology at your organization? If I can just ask you and the audience, please, to select one of the options, then we'll just get some view from the panel side as to the audience that we have listening to us. So if you wouldn't mind just selecting one of those 4 options, that'd be great. Just give you a few minutes. Interesting to get a view, actually. I don't think any of us in the panel have got a perspective as to what's the profile of the audience is. So this is very interesting to us. So I hope you're all selecting one of the options. We don't see until we've switched off the screen. And there we have it. So, well, that's very interesting. It's a relatively even spread. Obviously, a lot of people using it on projects and regular use, but there's still quite a significant minority exploring and having proof of concept conversations and investigations into it. Well, that's very interesting. To the panel, is that what your perception is from the market? Does that pretty much match your view, Hamzah? I mean, where's your situation?
We're one of the larger kind of general contractors, design builders, so we're constantly using it. But I'm not surprised to see that there's still a lot of exploration and proof of concepts, especially when you're talking about anybody within the ENR kind of like lower half of the top 400. So yeah, that's been out there.
Well, before we get too involved, let's go on to the second topic. And the second question we've got to ask you, the audience, is what are the other data sources that should be considered in addition to scanning technology when creating a construction digital twin? So if you wouldn't mind just giving us your view on that, what are the other data sources that should be considered in addition to scanning technology when creating a construction digital twin? Great, so I hope you're all selecting one of the options. That's fantastic. Appreciate your input. Good, so there we go. Well, all of the above, I think that's very interesting that, it matches my expectations. Any comments from any of the panel on if they're surprised by the outcome of this particular poll?
From my perspective on the software side, I would say that it's good to see that people are starting to realize that they need more than a good point solution. And there's been a lot of great point solutions over the last years, but expanding that data across different platforms for different needs is a big need. And it's nice to see people see that now versus I got the best point solution, I'm only in my little silo. So that's very nice to see.
Good. Okay, so let's get started on the conversation of the day. And I'd like to open up the floor with a question about AI and augmented reality. And the question is, what roles do AI and augmented reality play in the use of the intersect of scanning and construction digital thread? Let's start at the beginning. Corey, what's your view on that?
So from our software side, the use of AI, one example that's very nice practical is regularly scans of existing structures, monitoring crack detection and understanding, is it growing, is it getting larger, is there more? Those are things that are very tedious to do for bridge inspectors in just one small area, but it's critical because shutting down a bridge, doing all of the manual visual inspections is a challenge. With scanning technology and AI, now you can actually get in and focus on focused areas very quickly and save time, be safer, and get the roads back open quicker. So just a small part, but it's a huge benefit for our users.
Steve?
Yeah, backing up what Corey just said, I mean, the idea that you can take the unstructured data set from a drone or from a scanning camera or anything like that and actually interpret it with artificial intelligence means that you're lightening the load on the inspector. And if anybody here has ever looked at a big data set from a drone, looking at nuts and bolts on towers, it's not something you want to do for a long-term career. And you miss things, you know, you get bored and you miss something. So, and we don't want to miss things. So if we can create exception-based reporting using AI that flags up everything it thinks is an issue. Now it might miss things, so it might flag up something that's got mess on it from graffiti or birds or whatever, but at least it highlights the areas where you need to focus your attention, and you may only be examining 100 photos instead of 15,000. So it greatly reduces the amount of time and commitment and expertise of the person. Because the thing is, these mundane jobs need people who know what they're talking about to do them. And it's not something you want to give somebody with no experience, and the people with experience don't want to do it. So, you know, catch-22. Also, I mean, things like recognizing components so that they can be automatically populated in a BIM model is something that we're focusing on at the moment. So we recognize a type, a make and model of an antenna. We then pull it out of our BIM catalog. We use the point cloud that we've generated to work out its spatial dimensions and positions, and then we can overlay that into the BIM model automatically, so we get a fully autonomous scan-to-BIM solution. And again, the augmented reality can be used to double check that what you've got on your 2B design is actually in the as-built, because you could overlay that on your phone, hold your phone up, make sure the silhouettes match. And again, you can use AI to do that, or you could do it by yourself and see where things aren't lining up properly and raise that in your construction report. So there's lots of opportunities for AI and this kind of thing in that area.
Matthew, do you agree with that? Is that what your focus is on?
I think it's definitely aligned to what Steve and Corey has mentioned. AI in this type of environment is essential at the end of the day, because what we're doing is we're generating massive amounts of data. And we've seen with the advent of things like ChatGPT, where you take a whole bunch of data, condense it, make sense of it, and be able to move through that data set quite quickly. And I think that's what AI will allow us to do, is not just digitize quickly, but also to segment, classify, inspect, and basically make some of these processes autonomous. And that's where it needs to head to. AI would be the actual instigator and starting point for autonomy. So yes, it's absolutely essential.
Okay, Hamzah, do you actually use AI technologies within your business?
We do, and mostly it's kind of like concurring with everything that's been said already, but it's for us kind of like a construction project is changing on a daily basis. So when we're scanning, we are constantly trying to see what was it installed in the right place, and are we on track? And that's where kind of like the AI component comes in, where it automatically identifies specific pipes or ducts and compares that to the model and say, wait, you actually installed the duct maybe 6 inches off of where it was designed to be. That might not be an issue today, but that might be an issue 3 months from now when somebody else needs to install something different. So yeah, we're constantly looking at that, and then the AR piece of it also is to help us making sure that people on the job site are actually visualizing the design correctly and seeing where their installations need to happen. One thing that we're seeing right now in the AR world, which is kind of like what they refer to as like space consistent and persistent tags. So I can place a tag in our augmented reality world and tie it to a specific element on the job site, and somebody else comes in after me and they would kind of pull up the iPad and they would still see that same comment that I left on that specific element. So it's always kind of like continuing to feed that construction digital twin and making sure that it's up to date and everybody's on the same page.
Right. So that's very similar to a 3D tag in 3D space. Right. Great. Yeah. Andy, any comments? Any thoughts?
Yeah, I mean, I'm most delighted to hear everyone talking about specific use cases for AI, because there's a horrible tendency in the press and general media to say AI like it's a magic spell. It's going to solve everything and do everything. But what we've heard here is two things: specific use cases of AI to solve specific problems to improve people's lives, working lives. And the other thing was actually making that data and that analysis part of a workflow, part of a process. Because again, there's been a rush in the construction sector that I've seen to invest in technology, and it's become an investment for the sake of it. And I'm a passionate believer that if data and applications don't talk to each other, if you don't have joined up workflows, all you're doing is just creating another silo. So using AI to process data and make it useful upstream and downstream in the workflow, I think is really good to hear.
Yeah, I mean, I'd have to agree. I think we've far too often hear of technology for technology's sake. So I'm delighted to say that this particular nuance and technology base is actually moving forward much more rapidly, I think, than we've seen in the past. So in the topic of BIM, is scan-to-BIM something which is absolutely important to the construction industry? Is that an essential, Steve?
I don't know that it's 100% essential at this point in time, because it's not 100% achievable at this point in time. So as we go through the world digitizing things, then those things can get added to the BIM catalogs. We can train AI to recognize them, or machine learning to recognize them. It's not AI for object detection. And then we can leverage AI algorithms to make use of them. But it's a long road, and it is the utopian position. The idea that you could go to site with a laser scanner or a drone and end up with a full digital twin of your site in BIM without touching the keyboard is something I think a lot of the people on this panel would like to have. But it's not there yet, but we're getting there slowly. It's one step at a time. It's a very iterative process.
Hamzah, how far are you along that road of nirvana?
Yeah, no, that's spot on, Vice. I mean, it does take a lot of effort and time to get from a point cloud to a BIM model, like a complete BIM model. But what we're seeing is, because we are fortunate enough to be a design build company, so we have the designers that are actually, putting the work in the design aspect, and then we're building it. So we have a model to start with. And that helps us. Why? Because consistently throughout the project, when you continue to scan and find those, anomalies or changes or deviations, you can quickly change those little things throughout the project. And that way, when you get to the end of the project, you're not having to convert a whole point cloud to the BIM, right? It's like you're constantly changing that throughout the project, so that when you get to handover time, you have an as-built model, right? And it's as close as we can get it. Of course, we don't want to give the client the point cloud, that nobody can do much with the point cloud. You have to have, very powerful computers to process them, to look at them, to interact with them, or you're using some cloud-based, like Cin2 or Preview 3D that enables us to view those, right, and put them in front of a client, just so that we can say, here's how it looks, but here's the model, here's the actual model that is reflective of everything that we installed. to the best of our abilities. And of course, it's on them from that point forward to keep updating it if they change things.
Matthew, from your point of view, is it essential, or is it how important is it?
I think it's very important. If you look at the value drivers for any capital project, it's going to be saving time and saving money. So if you look throughout the capital asset lifecycle, if you follow certain benchmarks or certain type of guidelines like the ISO 19650, for instance, for BIM, how to document that process using laser scanning and other mechanisms, it's absolutely essential to get to a point quickly, cost effectively, and safely. So yes, I think it may not be in all instances essential, but it is definitely, you'd be stupid not to do it. So yeah.
And Corey, do you agree with that? I mean, have you got other thoughts on it?
Yeah, I don't know that we have the right answers yet, but one of the things that we've seen is when you build a basic digital twin and you're doing a design like they've mentioned earlier, there's so much rich data in that whole construction lifestyle process. And it's, do I bring in the reality data and create a new pipe because I already have a design pipe, or what's the best tool? If it's not in the right spot, like you mentioned earlier about being 6 inches away, do you keep the BIM model that might already be there and reference that and then clip that out and say, we're out of spec, we're out of alignment? Do I use the whole thing? It's a different world also for me when you are building a digital twin and you have that information versus retrofitting an existing project. In an existing project, a lot of the times it's probably better to scan to BIM to get your basis, and then you start adding and augmenting on there. So, and then also I deal a lot with infrastructure, roadway. Scanning to BIM there is a little bit difficult because most of our stuff gets buried. So getting a very good accurate scan of the utilities, things like that, is the value there for performance, for access, for whatever. So there's always, I don't know that we have the right answer, but I do think it's something that we do need to advance on.
Right. And Andy, you've obviously got quite a few of your clients active in these sort of areas. How important is this to them? I mean, the general software business.
It's treated as hugely important, but I think it's key to remember the distinction between what we get from scanning, which is a huge amount of data, and actually what's implied by BIM, which is not just a model. BIM information management is about actually more than just the physical shape of the model. It's also about all the components and the structure and the buried structure in the building or whatever the asset is that we're talking about. And I think we're a long way from having AI or other tools that are actually going to turn captured scan data into genuinely useful information for doing something with. The tool that Corey referred to earlier, which processes images and actually gives you information like a crack in a piece of cement in a bridge or something like that, that's information that you can act on. But pure scan data by itself, unless it's been processed, I don't think actually counts. So I think with that caveat, scanning and BIM definitely interdependent, but they're not the same thing. We need to be careful.
It's a good point. And I mean, I suppose that brings me on to the next question, which really is about how accurate and detailed can scanning technology be in capturing the physical sites and its surrounding environment, of course. And give us some indication about the limitations and the challenges with the current technologies. I suppose if we ask Matthew, you're in the business of scanning. I mean, give us some clues, give us some advice.
Yeah, I think, well, there's a lot to answer in that question. I think if you're looking, first of all, if you take the accuracy component, it's horses for courses at the end of the day. If you're looking for something that is sub-millimeter specification to make sure that the HVAC fits exactly right, you're going to use a very high density, high accuracy laser to measure that. And so there are different tools and different processes and stages and cycles of the building process that will align itself to the requirements. So looking at floor flatness, for instance, if it needs to be a warehouse, it needs to be 100% flat floor, get a nice high detailed scan, high accuracy, millimeter accuracies, and do that calculation and do that analysis. But if you've got the digitization of an existing infrastructure, for instance, it's a building that's being renovated, and you want to do a quick as-built and then another floor change with some prefab walls in between, you don't need a lot of accuracy, and then you migrate more towards something that's handheld and slam-based, which will be run about 10 mils. So it depends on that type of accuracy and that type of usability. I think the limitations of the technology, it's still a line of sight instrument. A lot of the terrestrial laser scanners, for instance, would be, what you see is what you get. But there's the advent now of drone technology with lasers on, or flying laser scanners that can actually, elevate higher than that and capture more data quickly, and you mitigate risk as well. So there's a lot of components that feed into that question. But yeah, accuracy depends on the task at hand.
I mean, Corey, what about from Bentley's point of view, the accuracy topic? Is it a significant issue, or is it something that is in process and improving?
So for us, a lot of and he mentioned a lot of it depends on what your outcomes are going to be from a lot of our users' perspectives. Sometimes you can get by with a quick scan, but I'm kind of old school. I like the accuracy, I like the technology, I like it to be tied down to tight control, because if we're doing a real true construction digital twin, that information is going to get used on elsewhere downstream for possibly reasons you don't know yet. And sometimes it's good to do a quick scan, not have the accuracy there. But in the end, somebody from construction, if they want to take accurate quantities, when you fly, say, a drone and you're scanning existing ground and then the grading, that's a lot of money in place. And if you're off a little bit, and we've seen that, with not having accurate control and whatnot, that's kind of a scary situation. It's not that the technology isn't there, and it's not that the equipment doesn't do it, it's the people. Everybody thinks they can fly a drone, scan it, be real quick, and turn it around. But boy, if they mess that control up, that's a huge number for payment. The accuracy, I mean, it's just, so I don't really think it's a technology or equipment problem. It's an understanding by the workforce who's going to process it and do it. So,
I mean, Steve, this plays to your comment earlier about the human factor. Would you agree with Corey on that?
Absolutely, yeah. I mean, we use photogrammetry models of towers to measure heights of antennas, for instance, or measure the surrounding compound, like how much area do we need to concrete and all that sort of stuff. But then we also use a photogrammetry model to work out where the tall trees are in relation to the antennas and if they're potentially causing a problem. And those three different use cases need three entirely different sets of resolutions, because if you're modeling something for the landscape and you're only interested in trees to the nearest 5 meters, you don't really need the resolution that you're going to get from a high fidelity laser scan. But then saying that, if you're sending someone to site to scan it, the biggest cost in getting someone to site is usually getting them there and having them on site. So while they're on site, they might as well leverage the technology they've got and make the best model that they can possibly make. So when we go to site, we laser scan it, we drone fly it, we do big overview models or data captures, and then we decide which models we need to actually make the detailed 3D models of, and we take the specific data set and process that, because we don't want to be sending it. North America, for instance, I mean, you might have to drive for 3/4 of a day just to get to the site to do the scan. So you don't want to be going back there 3 times to do the 3 different scans. So yeah, now we've got the technology available, we do as much as possible. And obviously that technology is only getting better. The resolution of cameras is getting better. Photogrammetry is pretty well established now. Laser scanning is incredible. The SLAM LiDAR solutions we found are not as accurate as their photogrammetry techniques in certain circumstances, but we are modeling quite difficult things to 3D model because they're very tall, very narrow, and most of them are see-through because they're lattice towers. So it's the worst case scenario for a photogrammetry system to model a lattice tower. So so we try and do everything, and that way we can combine the different technologies and get a good overall result.
Hamzah, do you associate with some of those challenges and some of those observations?
Yeah, absolutely. That's the never-ending debate. Is like, do I want a tight millimeter level and I want to spend half a day scanning it, or do I want a centimeter level and just an hour scanning, right? So we try to kind of pick and choose which one do we want to do based on the use case. So right, so as Matthew was saying, if you're casting concrete and you want to make sure your floor flatness is correct, then you want that millimeter level and you want to spend more time and effort in getting that detail. But if you're just walking the job site just to capture how much installation did we do this week and is everything in the correct place relatively, then really, I mean, we found SLAM scanning is very quick, or even 360 cameras that we can reconstruct to show a point cloud. It gives us very, very good measures, right? And that's kind of like the debate, or it's really understanding the value. What are we trying to measure? How are we trying to get to that? And choosing what tool that would help us get there faster, if that makes sense.
Yeah, absolutely. I mean, a question that comes to mind, Andy, is this an issue with we're not able to process the information quickly enough, which means that we've got to have these various levels of fidelity, or is it really a, you know, well, we actually don't need anything better, so we don't need to try too hard? I mean, is compute an issue here?
It can be, but by and large, if we're talking about scanning on site, before you can do any serious computing, you've got to upload it somewhere. And that's going to take more time than the compute time itself. So I think Hamzah hit the nail on the head, really. The answer to your question is, you know, how long should you spend doing scans? The answer is, how long have you got? Because if you've got a long time, then you can get a great accuracy scan. But if you want something quick every day by an unskilled operator, then a SLAM-based solution is often just fine. And it's choosing the right tool for the job, and you know, based on payback, really.
Right. Well, I mean, some good examples we've had already, but let's move on to the next question, which are the best practices. And I'm sure the audience will be very interested in your observations about best practices. Steve, why don't we start with yourself? Give us some best practices for incorporating scanning technology into the digital twin and thread.
So the most important thing for us is data consistency, because we're operating in 160 countries, and every single person you'd speak to who's going to do a scan for you is an expert in their field, and they've got the best way of doing it. And trouble is, we've trained AI on certain data sets. So we need the data set that's collected in Texas to be the same as the one that's collected in Chile and India. So so that way the AI has got half a chance to actually recognize things, or else you need to train your data set on individual data. And as somebody said earlier on, it takes a lot of training. I mean, to get reliable AI image recognition on a component, you need about 35,000 pictures. So so that's a lot of surveys before you can even baseline to use AI. So it's a massive investment. And so data consistency is crucial. We need the same, roughly the same, it doesn't have to be exactly, but we need roughly the same angles. We need to look down, we need to look up, we need to look level, and all this sort of stuff. And then that way we can centralize the engineering work with our design units, and they can take that data and they know they're getting consistent data, so they don't constantly call the person that did the scan and say, what did it look like in that cupboard? You know, that you've got to capture everything. And the thing we found is that when you've done a scan, somebody might be asking a question about the life expectancy of the fire extinguisher on site, or when were the batteries last serviced. And if you've got a recent scan, you can go in and read the text on the front where they've written on it, next service due at this time. And so you're getting data you don't even know is valuable to you until somebody asks for it, and then you've saved a truck roll and you don't need to send someone to site to do that. So yeah, I think consistency is the key for our application.
Right. Hamzah, is that consistency the same within your business?
Yeah, I mean, but again, it all goes back to the value. I think understanding what you're trying to deliver and what you're solving for. To me, that's like step one, is like, what are you trying to measure, right? If you're trying to measure anchor bolt tolerances, then you can't really use photogrammetry, so to say. So that's kind of like step one for us, is like, what are you trying to do? And then pick the right technology that would solve for that, and then send it out. But consistency is definitely important. And one of the part is what we're trying to also kind of harp on is, one thing that we usually not even include in these conversation about digital twins or even reality capture, which is like underground utilities. That's a big point for any general contractor out there, because a lot of the data that we have, like the as-built, underground utilities, are not accurate. So scanning GPR, ground penetrating radar, or even what we're working with rod radar and live dig radar, that information also is that a lot of data that we use, that we consume, that we bring in-house, and try to make sure that we are modeling all of those underground utilities accurately, not only for us, but now also for the next generation that's going to come to build later on the same site, that they know where those utilities are. Because up here you can see everything, but underground you cannot actually see it.
Yeah, interesting. Matthew, I don't know if your business is about scanning, so how do you sort of face the challenges that Hamzah's got?
Well, I think at the end of the day it all relates down to the specific industry. It relates to the specific asset. It relates to the people working on that asset. And most importantly, it relates to their digital maturity. So where are they in that adoption curve when it comes to understanding, like Hamzah has mentioned, looking at underground utilities? A lot of people would just take what they have because there's no other means for them. They haven't adopted GPR technology as yet. If people are looking at very high specification laser scanning requirements, they haven't invested in a terrestrial laser scanner that can do that yet. So they will settle for second best. The processes that relate that data into models have not been thought of yet. So it all speaks to the digital maturity, your adoption to that technology, and where you sit. So best practices will probably be dictated on the level of digital adoption where you are in that specific project.
Right, excellent. And Corey, have you got anything to add to this sort of best practice and examples, advice?
Just to reinforce what they've already said, the consistency of the data, the control is key. One thing, let's get back to the human perspective. If you're doing stuff, he mentioned, Texas, Chile, and all these places, with the cloud technologies and collaboration, it's not always people right there on site that are doing the inspections and viewing the models. So having the consistency, you actually are now spreading the workload. There's a lot of folks that, it's too expensive to get people there. Doing it remote, getting a consistent output that is accurate is probably one of the biggest keys, because if you don't trust the data and you got to manipulate and do stuff, then it just becomes a compounding problem. So just reiterating what they have is consistency is key, and also understanding what the outcomes need to be. So when to set up what level of accuracy and so forth.
Good. So, we're sort of running out of question time, because we would like to leave some time for Q&A from the audience. But a question I thought about, which was quite interesting, is what are some of the potential risks and drawbacks from relying too heavily on scanning technology into the digital twin? I mean, have any of you got a view on that? Are there any potential gotchas or things that people should be aware of? Anybody want to answer that question?
I'll take a stab at it, just because of massive amount of data size. That's always the bottleneck of where are you storing this, how are you processing it, how are you getting it to the hands of the end users that's going to look at that data and actually have an insight out of it. That's always the bottleneck, and the sooner you figure that out, the better you're going to be.
Okay, Anybody else, Corey?
I've got to say, it sort of goes back to question 2, really. You know, the all of the above option.
Yeah.
You need to be able to take data from several sources, because if you're reliant on drones and then you get a job somewhere in a country where you're not allowed to fly a drone, you need a solution to that, because the job doesn't go away and you still need to deliver it. So, so being able to adapt your processes because you've got many sources of truth, it may not be quite as accurate if you've got a hand-drawn sketch of a site, but at least you've got some sort of form of data that you can start with, you know, like, and then you can use your photos that they've taken on site to verify that that drawing is accurate, and so on. So you can't be reliant on a single technology, because if you do, then you're just setting up to fail. One of the instances we had, BLK 360 laser scanner. It's got it's a Leica product that Matthew's very familiar with, I'm sure, and it's got a thermal imaging sensor in it. Now, thermal imaging sensors are not allowed in certain countries, so we can't do a laser scan using that scanner in those countries because we're not allowed to take it in there. It gets taken off us at the airport, and that's quite an expensive thing to lose at an airport because you never get it back again. So, and the same goes for drones. You know, like some countries don't allow the use of drones, particularly in or around military infrastructure, which quite often is very closely aligned with the telecommunications network. So, so you can have some bureaucratic nightmares trying to fly drones in some countries. And so if we can get the drawings of the site and the other stuff, then we can build a model anyway. So that's the thing.
And Andy, you mentioned the sort of the challenges of, you know, data to source. Any other issues that you've come across from your other works that we should be aware of?
Oh, sure, yeah. I mean, one of my persistent bugbears is all of this scanning, all of this data capture. First of all, as Hamzah and Steve said, wherever it comes from, whatever device you've used to capture it has to be made available to anybody who might want to consume it, because you just don't know every use case when you're out there collecting it. So it's got to be available, but it's got to be consistent with each other. So if I've got a structure and I want to know what the underground assets are, they've got to be aligned. So you know, if I dig a hole in the ground, what I'm going to find there. And that's also got to be aligned with the BIM model. And something I was most disappointed on one of the surveys was tying it in with project management, because things change and people make mistakes, and it doesn't matter. Often it doesn't matter so much that they made this mistake as much as you know what it was that actually happened, and that branch or that revision control gets built back into the master data model. But yeah, one of my great passions is, what's the point of going to all the trouble and expense of collecting all this brilliant, accurate as-built data if it then doesn't get handed over to the actual operator of the asset that we've built? And that handover to CAFM or to building management system or a censored up asset in the field, I think is the last piece of the puzzle that I just don't see happening often enough in real projects. You know, maybe that's the next big wave for actually using digital twins in construction properly, is getting the live data back from the field.
Yeah. I mean, we can I just remind the audience, we'd love to hear your questions for the panel, so please get them in. I'm going to ask one last question, which I think is the big one for me, which is, how do you see scanning technology evolving in the future? Matthew, let's start with yourself.
Yeah, I think there's been a couple of mentions throughout the discussion. The current drawbacks: large data, transferability of the data, processing time, accuracies, these types of things. I think the future would probably see more and more mobility, quicker scan times, quicker processing times, more intelligence being built into the processing part, so automatic classification, automatic object detection, extracting certain end deliverables from that scan automatically, autonomously as soon as possible. So I think that's where things are moving towards, and also making sure that, as Andy mentioned, all the areas that are scanned and all the data that's produced are aligned to each other and actually speak to each other. So when you have that downstream data flow or aggregation where it gets together together, the models and the scan data and everything fits together, is in the right orientation. So yeah, quicker scan times with more deliverables autonomously, I think.
Okay, Curry, how about from you?
So one of the challenges that I see is, again, the sheer size, but where do you store this? How do you access this in 5 years, 10 years? When do you retire this stuff off? Do you ever retire it off? And I'm a software vendor, and while we talk about interoperability and open source, it is a challenge because, as Steve mentioned earlier, you got some that we're going to have thermal imaging. There's going to be some that have photographs, some that are just LiDAR. Where do you store all the images that go with that? It's not like a BIM file where you can just send over a file. You can kick out an IFC. I don't think this industry is that far off course. Everybody's got their own proprietary formats. We can all read pretty much everything. But it's, again, how do I keep it? How do I surface it up later? And if there are problems, issues, like one of the guys mentioned earlier about putting an issue on it, how does that continue on? Because that was put on by proprietary software. Can somebody else read that issue 2 years down the line and understand what's going on? So I think we're getting there. Saying everybody's going to be open and universal, I'm sorry, it's never going to happen. Everybody's got their own needs and wants and outcomes, and we do our best, but that's going to be the big problem. Keeping it useful beyond.
Beg your pardon, Steve.
I mean, I come from Ericsson, and we're into 5G, Internet of Things, and stuff like that. So I'd like to see things going towards if you can put a sensor on it, report into the network. With 5G speeds and connectivity, the scanners could be reporting live over 5G. I mean, we've got ridiculous bandwidths now available over the 5G phone network. We could theoretically be uploading laser scans in real time and affecting decisions whilst we're still on site based on the results of that scan. Same thing with photogrammetry. You could stream the data direct from the drone into your servers that generate the photogrammetry. So as we go on with a connected world that we're seeing, and Industry 4.0 and all that sort of good stuff that's going on, this is just going to integrate more tightly. And to Corey's point about the standard thing, I mean, that is incredibly important. The fact that I produce a BIM model, I want you to be able to read that BIM model. And all of the stuff that we've been developing has been in accordance with the ISO standards around BIM, so that we know that our customers can take that data and import it into their own systems without buying into the ecosystem that we bought into. They've got their own stuff. We don't want to make them change. They've just got to be able to use what we use. And the sooner everybody starts doing that, then the happier these things will be to talk to each other and integrate together properly. Because our idea is that the BIM model should stay with that site for life, and any updates, moves and changes should be updated using a field client or some other methodology. But I want to be able to click on something in a BIM model and see what temperature it is at the moment. What software is it running now? When was it last upgraded? Who installed it? When was it installed? And all this other stuff, that you can get from that just by integrating these systems together. The data is all there now. You just need them to talk to each other and say that story. So we can build a proper life cycle management tool with the data that exists today. We just need to think about it and make sure it's all standardized. That's
Hamzah.
Yeah, that's really where the most value is going to come, is how do we make everything talk to each other? Because again, by the end of the project, we're compiling everything as an as-built model and handing it off to the client. But most of the time, the client is like, I don't know what to do with this, right? So we actually, even within Haskell, we created our own platform that would help the client visualize and look at all the data, look at the drawings, look at the scans that were done, look at everything, and it's all compiled in one platform. And it's of course optional. It's not like we're trying to force it down their throats or anything, but we're trying to help as much as possible our clients to have access to that data and be able to see what's happening in their facility and how to update that throughout the years, because that's where you're going to get really the most value out of it.
Okay, Andy, have you got anything to add very briefly? I'm going to go on to some questions in a second. So,
well, yeah, the tempting answer to your question is metaverse, the other magic spell for solves everyone's problems. But I believe that as much as I believe Second Life should still be around. So no, I think say I'm pragmatic point of view. Let's understand what the problem is that we're trying to solve and provide a solution to that problem.
right.
Client by client if necessary. Standards are great, but if I need to solve a problem today, let's use what I've got today.
I know that your colleagues, Andy, are going to be upset. I'm going to just skip the next poll purely because we've got some questions coming in. I think it's important to answer some of the questions. Any that we can't answer, by the way, we'll get back to you afterwards. But there are a couple of questions that have come in. One from John Callan, who I happen to know from Lutron. And he asked, how comprehensive is converting cloud point data into analytic geometry? And are hybrid systems, that's analytics and cloud points, effective at representing a building? I think that's the first part of his question. Who would like to take that? Anybody?
I think that's a Bentley system.
It sounds like a Bentley question to me as well.
Corey, are you happy to answer that?
Well, I would probably push back to Matthew with Leica. They actually control the scanners, but Bentley processes the data that's coming in, and the accuracy is from obviously the equipment and those. But I mean, that's the scanning to BIM and the accuracy and those things. Again, all that, as we've been talking, is it photogrammetry, is it LiDAR? All of those things do make a difference on how you process, what tools you're going to use, what adjustments you need to make. I do know, not just Bentley, but everybody, you know, we all have our own set of tools that will do that, but it's a challenging problem right now. I don't know that there's a great answer and there's a great solution, because you got to get all sides to get an accurate model. You got to have the control. I mean, it is an ongoing. I don't know that there's a good answer. I hate to say it that way, but the accuracy is dependent upon the use case and the equipment. So I'd ask that to expand.
Sorry. Didn't mean to interrupt, but there is a follow-on from this from John, which probably Matthew might be able to help with, which is what about scanning beyond locations, things like texture, material, transparency, etc.
Yeah, I think as we move further into the future and with AI, you know, classification would start to emerge where you will be able to tell what type of material type it is, what type of construction type it is, assign that to an IFC classification to help you understand that downstream. So I think those types of technologies are being looked at, and it's something that is not impossible. But I think, you know, once again, it boils down to, as Corey said, you know, horses for courses, you know, sticking to the process, getting the deliverables that you need to have, and the accuracies that you need to yield from that. But as it's moving towards automation and autonomy, you know, these types of technologies are emerging.
Right. I've got a couple of others here. What about coordinate systems, which is a challenge if BIM and GIS people are talking obviously in a different language? Hamzah, do you see that? I mean, is that something that's a problem within your business?
All the time. So our civil engineers are always, you know, working on the right coordinate system, but then our designers, architect, everybody else is in their own world in 000 land. So like trying to compile those two together is always a challenge. But also getting the data from the field, it's a challenge to line it up. And that's, I think, what Corey was mentioning is like the importance of having that control, right? So you know where your control points are, what their coordinate systems are, and then kind of try to tie everything together. It's not simple, and it's an ongoing pain point for sure.
Right. And just the final question. Well, in fact, I think think that's it for the moment. Oh no, there's one more. Big pardon. What is the best project management solution if you are working with a lot of scans? I don't think we're looking at anybody to be too specific, but are there any words of advice for Peter Kontz, if I'm not mistaken, his spelling is? Andy, you got any thoughts on that?
I have to be diplomatic.
Very diplomatic answer. Anybody else want to take a stab at being subtly diplomatic on this? Corey?
I'll be as objective as I can. When you're choosing a solution, as you saw in the results, we are not dealing with point solutions anymore. People that do the scanning are not in a silo. So when you look at a system, you need to be able to handle all of the different types, the scale. That seems to be the big one. How do I process and handle the scale of scan after scan after scan after scan? And so when you are looking at this, it's not always the cheapest, but you need to understand that the scale and scope of how much data you're dealing with, the accuracy, the outcomes that you need. So, there is great softwares with each individual vendor, but you also then have to take a look, does this output work with multiple systems? Because your customers are going to need whatever system. So I would say just look at, more of an enterprise level looking type software versus a point solution. That would be my advice.
Thanks. And Steve, so just to sort of conclude, like 20 seconds from each of you, and I'll start with you, Steve, because I'm sorry we missed you on the last one, but any words of advice to our community out there listening to this conversation?
No, I think we just need to leverage the best technology that we can afford to use to do it, because you can never, as we've discussed already, and I think that message has come through, is you can never have a good enough scan. So the better the scan that you get, the better the data you've got to play with. Okay, it costs more and it costs more to store, but you've got it. And sending people back to site includes risk and expense. So that's my 10 seconds.
Excellent. Hamzah, 10 seconds from you.
I'm going to push back a little bit on Corey and what we love working with point solutions, but the key is to have them all integrate, right? So yes, we have a single source of truth, and for us that's Procore within Haskell, but it could be any other tool for project management. But it just means that everything else that you're processing data in or actually get an insight from is talking to that and storing data or pulling and pushing back to. So that's how we would do it at Haskell.
Great. Matthew?
Yeah, I think if anybody's looking at chasing up the digital twin, is to partner with a company that can provide solutions, as Corey mentioned, end-to-end situation, but also look at the digital maturity of where you are, what is realistic, and how to approach that, and then grow from there. Everybody has to start somewhere, and not everybody's got it right. So do what you can and grow from there.
Okay, Corey.
So yeah, I would say organized, structured data, consistent, processes and workflows, because as you said, we're not all there yet, but we can improve on what we can't measure, and you can't measure what's not consistent. So I would just say, build very good practices, and then from there, it helps to incorporate the software companies so we can make improvements and make the jobs more efficient from our perspective.
And a final word from you, Andy.
Yeah, thanks. I'm so pleased to hear people talking about joined up solutions. I think it's absolutely essential from the BIM modeling through to reality capture during construction, through to facility management and in-life use. But I think there's a quick win that seems to be overlooked, and that's at end of life. When it comes to demolition and dismantling structures, I think this is an area that reality capture could give real quick wins for analyzing content in buildings for urban mining, recyclability of existing structures. So I think that's a real quick win that I haven't really seen many people exercising in the industry. So
Well,
let's see true life cycle management for these assets.
so some excellent points, and thank you very much to our panel, Corey, Steve, Matthew, Hamzah, and Andy. I hope you've enjoyed this. I know we've run out of time. There are some questions to be answered, and they will be answered afterwards by our colleagues at AMC Bridge and the panelists. Thank you for listening, and I hope you've enjoyed it.
Thank you.
Thank you.
Thank you.
Thank you.